Hi everybody. We would like to begin with our chapter 1 for the beginning of our course. Chapter 1 talks about the introduction to statistics. So I'd like to start our introduction by using two examples that you can see quite often either from TV or reading articles. Example 1 here talks about weather forecast. Chance of rain in Charlotte area tomorrow is certain percentage. Now let's assume tomorrow is going to be sunny, so the chance of rain is going to be 0%. Example 2. Of people in the United States, 14% said they feel happiest in June and 14% said they feel happiest in December. Over here we've got 14% as a percentage, 14% as another percentage. Both talk about the rate of happiness, and these two are considered to be statistics as well. Going back to the example 1, 0% over here is one statistics that we'll be looking at in the future. So next we're going to talk about very briefly many disciplines that use statistics. You see in business and economics we use statistic data to kind of make analysis of what's going to happen to the economy in the future, and also make certain analysis to the economy in the back. In the social science and also natural science, we use stats a lot, especially when you're doing experiments, right? Physical science the same, education, you can use the data analysis to see how the students are doing. Politics, we see that quite often when you're at those election seasons. The numbers that you see from the articles or newspapers, a lot of times they are from statistics. So next is a formal definition of the statistics that we are learning. Let's look at the definition and try to decompose that into several parts. Statistics is the science of, first of all, we're trying to plan. Oopsie. Okay, so planning, studies, and experiments. And then we're going to be obtaining the data either from experiments or survey or any other ways. And a lot of times the data are unorganized, so we need to organize the data, summarize them, and you may use certain graph or chart to try to present these data. After that, we're going to do analyzing and interpreting these data. To the very end, we're going to draw conclusions based on what you have seen from your analysis and interpretation. So in order for us to carry out all these work, we need to have some basic ideas of the vocabularies of the terms that we'll be using in stats. So let's look at the terms one by one. First is data, that we hear quite often in the news and articles, right? And textbook. So data, there are a bunch of collections of observations. These observations can be measurements from experiments or from survey response. It basically depends on what the purpose of your study is, what you're studying at. Next is population. So population consists of all individuals. So over here we are emphasizing all individuals, not leaving any individual one. Okay, so includes everything that is being studied. Next is census. So census is basically what you have got from every member of the population. So if you have done the survey, census talks about everything that you have already collected. Sample is what you have got from the population. A lot of times, population is so big, so instead of studying individual one, so here is population. So population. It's impossible for us to study the entire population. Therefore, you can take a group of subjects and study this group of subjects. And this group is called sample. So sample is a subset of population. In statistics, we'll be using sample a lot. That's once again because a lot of times your population is so big, we can't do a full study of every individual element in the population. So a lot of times we just take a representative sample. So let's talk about some rules for us to get the sample data. Sample data must be collected in an appropriate way. Okay. Such as you may have heard a lot a process of random selection. We're trying to avoid any methods that can make sample data to be biased, which cannot reflect the population in a good way. So the outcome of if sample data are not collected in an appropriate way, the data may completely be useless. Next is one example of population versus sample. Population can be the students attending a certain school, like Queens. Okay, so again, let's use Queens for example. Now, Queens is not too big, but still, it's impossible for us to go through each individual students to ask about their opinions if you're doing certain survey. So we can look at one particular class of Queens, and those students in this class, say our QLC 260, okay, 260. Learning community, certain learning community, that specific class, the students in this specific class can be considered a sample of Queens students. Next example talks about one statement that we've seen from some of the newspapers you probably aren't quite familiar. Some people responded to this request. Dial 1-900 pro-life to participate in a telephone poll on abortion. $1.95 per minute, average call 2 minutes. You must be 18 years old. So the population here will be all the person who have heard about this request. While sample would just be which people? The people that responded, right? The respondent to the request. So next question will be, is the sample likely to be representative of the population? So our question is, do you think the person who have participated in this telephone poll would be representative of all the person who would listen to this request? Most likely not, because those people who dial may have strong opinion, right? So this will be no, not a representative sample. So in another way, this is not a very good sample. So next part, we're going to talk about some of the principles of statistical thinking. Okay, includes context, source of the data, sampling method, conclusions, and the practical implication. When you are reading any statistical statement, or just for example reading some articles from a newspaper, you need to think about what's the context of the data that they have collected. So questions you may think about as, what do the values represent, and where did these data come from, why were they collected? Also, is the source objective or biased? Right? This is very important. Is there any incentive to have the source to be biased? Especially, you gotta be skeptical of studies from sources that may be biased. Okay. Sampling method talks about the methods for us to get the samples. Okay. The example that we just looked at about that telephone polling, the opinions about abortion, is so-called voluntary response. These are also called self-selected sample. And a lot of times these samples have bias. Let me highlight these. So they have bias a lot of times. So they are not necessarily valid. We should try to avoid those, include these samples in our study. Some other methods, such as random sampling, this is usually considered to be good. Okay. And again, because of the randomness, random sample. So again, let's look at the next example. In a study of the Weight Watchers weight loss program, subjects were found using the method described as follows. We recruited study candidates from the Great Boston area using newspaper advertisements and television publicity. Is the sample a voluntary response sample? Why or why not? Let's look at how they recruited the candidates. We recruited study candidates from Great Boston area using newspaper advertisements and television publicity. And again, in this case, only those people who are interested in the weight loss would be able to would be interested in getting into the study. So I would say this is yes, this is a voluntary response sample. Conclusions. For the statistical conclusions, we need to make sure the statements are very clear to those people who have no idea what you're talking about in stats. Okay. And avoid making statements not justified by the statistical analysis. In the later part of our course, we'll be doing statistical analysis. Every statement will be based on your analysis. Okay. So that's our part 1 of the introduction. Next time we'll be talking about the implications and more information of the intro stats. Thank you.